John Idelson from California State University, the California Virtual Campus, and it's my great pleasure to introduce our first speaker. I probably should go there. That's who I am, but you've seen me before. And hopefully we'll go to the next slide. There's our distinguished panel. And our first speaker, John.
Okay. Thank you for inviting me to speak here. I'm John Reeder, and I manage worldwide education for DLP, which is a display technology that I'll talk about in a second. So I'll cover my credentials and then focus most of my presentation on some work we're doing in 3D for education and the results that we've seen. So first of all, what is DLP? We don't make end products, but we do as a chip company. Of course, this is part of Texas Instruments. As a major semiconductor company, we make the display technology inside. This chip is used to project and display images. It's been in production since 1996, and it's used by over 30 brands. And we've shipped over 20 million devices in the last 15 years. And the applications that use that cover a very broad range. It covers everything from putting a projector inside a cell phone, also mainstream conference room projectors and classroom projectors that you're probably familiar with, all the way up to digital cinema. So most of the digital cinemas today actually have our technology inside. And as a part of that, we enabled many of the 3D movies that are out today. Use DLP projection. So the chip that's inside all those projectors, if you're doing a small one inside a cell phone, it would be that size. And that's a chip that's inside a cinema projector. This one obviously is designed for very small end products. And this one's designed to project up to a 70 or 80-foot movie screen, all with the same technology. Interestingly enough, the resolution of these two chips is both HD. And you can see how the technology scales and applies to a broad range of products. So with that in mind, the applications that I'm going to talk about for 3D are in education and really apply to that middle section, the mainstream projectors that you see in classrooms and auditoriums. And being a technology company, of course, we focus on innovations, and we have a number of them that we think will help educators with projection technology. And covering 4 of those, lamp-free. That's a new class of products that does not have a lamp inside. It actually uses solid-state illumination, be it lasers or LEDs. And of course, that means that the light source lasts the lifetime of the product. Another one is interactive. So, of course, the interactive whiteboards have been around for quite a while. But we actually embed a technology inside the projector. Our customers supply this that allows you to interact on any surface. You don't actually need a touch board of any type. It's always calibrated and in alignment, and hence it's portable. So even if the projector moves, it still can interact. Another is an optical technology, which is ultra short throw, that allows you to basically mount the projector on the wall. You don't have to have it hanging out in the middle of the room. And the 4th one that I want to focus on is really 3D for education. Now, of course, we did a lot with 3D in cinema, but we started to think about what if we had 3D educational content? And it turns out there is 3D educational content already available. What would that do in the classroom? Well, first of all, obviously you'd have a lot more engagement of the students, we presumed, because, face it, kids love 3D. If you go to a 3D movie on Sunday afternoon, the theater's packed with children, and they love the experience of that. But we thought that there's something much more important here, and beyond just entertainment or engagement, it's really helping children visualize complex spatial concepts much better with a 3D projector. And I'll talk about how we validated that. And then also, because our technology is so fast, we're able to enable 3D, and a projector can do both 2D and 3D for very little or no additional cost. So we started a series of pilot programs, first in the US and the UK, and then that is in the process of spreading around the world to include Asia, many countries in Europe, Australia, and South America. And what we wanted to do with this is really test the effectiveness of 3D. Does it make any difference in the classroom, or is it just an interesting gimmick? And I wanted to show a video. This is probably one of the more compelling cases to give you an idea of what happens when you bring 3D into the classroom. So this is one of our pilot program sites was in Reading, England, which is just outside of London. And they installed 3D with the glasses as well as content. And they set up a test where they taught, the first one was a plant cell. So you're probably familiar with this and the various components of that, nucleus, et cetera. And they used the same method of teaching in both the 3D class as well as the control 2D class. They used the same methods with one exception, and that is they did have a 3D model that they put up for 10 to 15 minutes, and they showed the plant cell in 3D, and all the children put on their glasses and were taught. And that was just basically to augment the standard instruction in plant cells. And then they asked the students, using standard construction paper, glue, whatever, to construct a model of a plant cell. And I think the results are fairly striking. So this is a homemade video. I'm not sure you'll be able to hear the sound.
3D.
So these are the models from the students that were taught in 3D. You probably noticed,
They've been taken apart for marking.
you probably noticed they're all 3D. This one actually opens up. You can look at the various components inside.
And these are the ones that were taught in 2D.
You notice that's the only one that's a 3D model. Everything else was in a flat 2D representation. So all the 3D students created a 3D model, and all but one of the 2D students created a 2D model. And the teacher did, to be fair, try to, in the 2D section, try to use their hands to represent that this wasn't a plant cell is not flat, it is a three-dimensional object. But I think the results of the modeling shows that that concept really wasn't grasped. So, you know, you think about how this would apply starting in elementary education, perhaps to teach the solar system, that moons revolve around planets and planets revolve around the sun. That's very much a spatial concept, and I think is much easier to grasp in 3D than in 2D. And then as you step through higher education, learning about various parts of anatomy, the heart beating, et cetera, and then moving on to higher education, which I know is the focus of this section, start thinking about, let's say, advanced chemical in chemistry, the models of various compounds, et cetera, or DNA, obviously, is also a three-dimensional concept. I think it'd be much easier for students to grasp all of that if they can actually see it in 3D. Geology, geometry, et cetera. So I just wanted to introduce this technology, and it is real. It is already here. And in fact, there's been over 1 million 3D projectors shipped already into the education space. So content is currently being developed.